So whenever a body is at rest, I call it as statics. Whenever a body is in motion because of the forces acting upon them, I call it as dynamics. Attach a string between two poles. Pluck the string. The motion of the string up and down is called as vibratory motion. A body is said to be in uniform motion if it travels equal distances in equal intervals of time. Hello students, welcome to this first session on chapter 2, Motion in a Straight Line, under first PUC Physics. I am Madhu R, your faculty for physics from Vidhyaashram PU College, your temple of excellence. Let us check the foundation course for first PUC Physics, which is regarding motion in a straight line. Motion in a straight line will also refer to motion in one dimension. Okay? Let us check some of the basic terminologies. What is mechanics? Mechanics is that branch of physics which deals with the various aspects of motion and forces acting upon them. What are the bodies which are in motion and what are the forces acting upon those bodies such that these bodies are in motion? Mechanics is classified into two branches, the statics and the dynamics. Dynamics is further classified into kinetics and kinematics. Let us check what are these branches. Statics basically deals with the state of a body at rest or at equilibrium. So whenever a body is at rest, I call it as statics. Whenever a body is in motion because of the forces acting upon them, I call it as dynamics. As I said previously, dynamics is further classified into kinetics and kinematics. Kinematics basically deals with the motion of a body, but it is not taking into consideration the cause of the motion. I am simply interested in the traveling of a ball. I am not interested in the force that is acting behind it. A footballer might have kicked the ball or a cricketer might have hit the ball with the bat. But kinematics is only interested in the motion of the body without taking into consideration the cause of the motion. Whereas kinetics is the study of motion of a body by taking into account what was the cause of the motion. Under mechanics, I study statics and dynamics, and under dynamics, I study kinetics as well as kinematics. So, statics deals with the state of rest, dynamics deals with the state of motion. Under the state of motion, kinematics deals with only the motion of the body without taking into consideration the forces acting upon it, whereas kinetics takes into account the cause of the motion. Now let us check what is motion and what is rest so that we can better understand all these terminologies. Motion is when any body changes its position with respect to time. Say for example, a car is moving along a road. If you are observer, if you are sitting at a point and observing a car moving along a road, with respect to each and every passing second, the position of the car changes from one position to another. This is what motion simply means. Then what is rest? Rest is the opposite of motion. Rest is when a body does not change its position with respect to time. The best example for that is you are sitting in a position and watching nature. A tree is a best example of an object at rest. It does not change its position with respect to time. Maybe 1 hour, maybe 1 day, maybe 1 year. The position of the tree remains the same. So motion is when a body changes its position with respect to time. Similarly, rest is when a body does not change its position with respect to time. Now let us check what are the different types of motion. The first one is a vibratory motion. How to understand vibratory motion? Attach a string between two poles. Pluck the string. The motion of the string up and down is called as vibratory motion. Similarly, the next one is linear motion. You push a box along a straight line. The motion of a car along a straight line, the motion of a bicycle along a straight line can be termed as linear, or it is also called as rectilinear motion. If a motion is happening along a curved line, then I call it as curvilinear motion. It is happening along a line. Both these types of motions are happening along a line. One is along a straight line, the another one is along a curved line. Moving on, I have something called as periodic motion or oscillatory motion. The best example for this oscillatory motion is the pendulum of the wall clock, wherein the pendulum moves from one position to another after every time period. Similarly, if there is a motion along a circle, then I call it as a circular motion. If there is a rotation happening along the axis, like in the case of a ceiling fan, then I can call it as a rotatory motion. So we can classify motion into different types like vibratory motion, rectilinear motion, curvilinear motion, rotary motion, circular motion, and oscillatory motion. These are few of the types of motions that we recognize in our day-to-day life. Now let us check and understand few of the terminologies that we will be using in this chapter on motion in a straight line. First one is the particle. What is a particle? Particle is essentially just a piece of quantity of matter having no linear dimensions. It does not have any dimensions, okay, but it has only position and mass. It has only a certain position which is recognized that this particle is somewhere here, okay. So it has got position, it has got some minute mass, but it does not have any dimensions. Next, what is an event? An event is a physical process that occurs at some point in space at any instant of time. It may be happening at any point in space at any instant of time, at a fraction of a second. At a fraction of a second, whatever happens in space may be termed as an event. It may be the collision of two particles. It may be something like that. Whenever two particles collide with each other, that instant of time when they come in contact with each other can be called as an event. Then, who is an observer? Observer can be a person, it can be an equipment. What does this observer essentially do? It locates, it records, it measures, and it interprets any event that is happening. So, whoever locates, records, measures, and interprets can be called as an observer. So, we have studied about a particle, an event, and an observer. Let us check what is the reference point or the frame of reference. The reference or the frame of reference, a frame with respect to which a position or a motion of a body can be described, is called as frame of reference. Essentially, the observer observes an event from this frame of reference. What can be the different sets of conditions under which an observer is observing? The object is at rest. The observer is also at rest. Then, observer moves at some constant speed. The object may be in rest. Observer moves at a variable speed. The object may be at rest. The other two conditions may also be the object is also in motion, observer is also in constant motion. Object is also in motion, observer is also in variable speed kind of motion. Okay, so these are the different types under which a combination of observer and an object can be viewed through a frame of reference. Now let us try to understand the two types of motions which are uniform motion and non-uniform motion. Suppose I am traveling on a vehicle. I am recording the time in terms of hours. After every hour, whatever is the distance covered, if I am covering equal distances at equal intervals of time, then I can say that it is a uniform motion. A body is said to be in uniform motion if it travels equal distances in equal intervals of time. I am traveling 10 kilometers per hour for every interval of 1 hour. First hour I have traveled 10 kilometers, second hour I have traveled 10 kilometers, third hour I have traveled 10 kilometers, fourth hour I have traveled 10 kilometers, so on and so forth. For every 1 hour time period, I am traveling 10 kilometers. It can be termed as uniform motion. Then what is non-uniform motion? When the travel is unequal distances in equal intervals of time. What does that mean? The time period remains to be 1 hour. For every 1 hour, whatever is the distance traveled, that needs to be taken into consideration. In this example, in the first hour, the car has traveled 20 kilometers. In the second hour, it has traveled 5 kilometers. In the third hour, it has traveled 5. In the fourth hour, it has traveled 10 kilometers. So, the distance is unequal for every hour of travel. Hence, it is called as non-uniform motion. Let us check what is motion in a straight line. Now, this is where we enter into the topic. This is where the topic of motion in a straight line for the chapter name gives a meaning for us. Any one-dimensional motion, any motion happening in a single dimension can be termed as motion in a straight line. If a body is moving in a straight line or in a single direction, it is known as one-dimensional motion. I call it as 1D. Sir, what if it is in 2D? If it is happening in 2 dimension, I call it as motion along a plane. That will be your chapter 3. Okay. So what is motion in a straight line? Motion in a straight line is basically one-dimensional motion. There is only one dimension to this motion. Now let us check 2 more important terminologies regarding what is path length and what is displacement. Let me try to explain this with the help of a simple example. Suppose I am standing in position A. I travel to position B. Then I travel to position C. Then I travel to position D. Then I travel back to position A. This is probably what you do when you go from your home to your college back to your home. Okay. I might have traveled some 5 kilometers from A to B, from 6 kilometers from B to C, another 5 kilometers from C to D, another 6 kilometers from D to A. So I have in total traveled some 22 kilometers. Whatever I have traveled from A to B, B to C, C to D and D to A can be considered to be the path length, the length of the path. Whereas my displacement remains to be 0 because I was in position A when I started. I came back to position A when I ended. So there is no change in the position. If there is a change in position, then it is called as displacement. Let us check the definitions. The distance traveled or the path length, it is the total length of the path traveled by an object. See here, this is the initial position. It travels in some direction and reaches the final position. Whatever is the length of the curve can be called as the distance traveled. It is also called as the path length. Then what is displacement? Please understand, displacement is the shortest distance. It is the shortest distance between the initial and the final point. This was the initial point. This is the final point. So whatever is the shortest distance between the 2 points, that can be termed as displacement. The shortest distance between the initial and the final point is called as displacement. Please remember, displacement is a vector quantity. It is measured in meters. Hence, its dimensions will be m0, L and t0. Displacement may be positive, may be negative, or may be 0. As I told you, if I come back to the same point, then your displacement remains 0. If I am traveling in the forward direction or towards the right, the convention is that it is positive. If I am traveling in the backward direction, the convention is that displacement is negative. Similarly, downward direction displacement is also considered to be negative. Upward direction, the displacement is taken to be positive. Okay, so displacement can be positive, it can be negative, or as said here, it can be 0. Please remember, the magnitude of displacement, the value of displacement can never be greater than the path length. Path length is always greater than the displacement because displacement is the shortest distance. path length can only be equal at some case. If you have traveled in a straight line, then distance is equal to displacement. Otherwise, displacement is always lesser than the path length. Okay. Now let us try to understand what is speed. Speed is the rate of change of position or the change of position with respect to time. Or in other simple words, it is the distance traveled by the time taken. I have traveled 100 kilometers in 1 hour. The speed will be 100 kilometers per hour. Okay. Or in SI units, I can say it may be around 30 meters per second. So this is how I generally call, or I generally try to denote what is speed. Unit of speed is meter per second, meter second to the power minus 1. Once I try to understand the speed, the next thing will be how I try to understand the average speed. See, let me take an example. If I want to travel from Mysuru to Bangalore, I generally get Srirangpatna, I get Mandya, I get Maddur, I get Chanpatna, I get Ramnagara. So I travel from Mysuru to Srirangpatna, Srirangpatna to Mandya, Mandya to Maddur. I travel across all these cities and finally I reach Bangalore. The speed from Mysuru to Srirangpatna, from Srirangpatna to Mandya, across all these cities need not be equal. They may vary. Okay, they may vary. So what do? I take the total distance traveled divided by the total time taken. Here I might have traveled some 25 kilometers in 10 minutes. Here I might have traveled some 20 kilometers in 12 minutes. Here I might have traveled some 25 kilometers in another 14 minutes. So on and so forth. The speed may vary between city to city. But what do? When I take into consideration average speed, I take the total distance traveled from Mysuru to Bangalore. It is 150 kilometers. I might have taken 2 hours to travel it. So the average speed will be 75 kilometers per hour. So average speed is the total distance traveled by the total time taken. Once we have understood speed, we move on to velocity. What is velocity? Velocity is also the rate of change of displacement. There we said that it was rate of change of position. I was only interested in the path length in speed. Here I take into consideration the displacement. Velocity is the ratio of displacement over time. The unit here is also meter per second. What is the difference between speed and velocity then? Let us try to understand. Speed is simply how fast you are traveling. I say speed of the car is 20 meters per second. Then what is velocity? Velocity is speed along with the direction. Here also I represent velocity by saying that velocity is 20 meters per second. But I don't stop there. I say it is in the eastward direction. It is towards the east. So the difference between speed and velocity is I only represent the magnitude here. I am not talking about the direction in terms of speed. Whereas in velocity, I am representing the magnitude as well as the direction. So whenever I am telling you the velocity, I will give a number saying that it is some 25 or 30 meters per second along east, west, north or south direction. That is the addition when you compare that with speed. Now let us check what is uniform velocity. If a body covers equal displacements in equal time intervals, it is called as uniform velocity. If it covers 10 kilometers for every 1 hour of travel, say for 5 or 6 hours, for every 1 hour of travel, it covers exactly 10 kilometers, then it is called as uniform velocity along with some direction eastwards or northwards. Okay. Then what is average velocity? Average velocity is the ratio of total displacement of the body by the total time taken. So it is taking into consideration all the displacements by the time taken. It is represented as delta x by delta t is x2 minus x1 by t2 minus t1. Let us now understand what is instantaneous velocity. Now, I'll take the same example of traveling between two cities. Okay, I am traveling from city A to city B. I may take some 1.5 hours to cover this travel. I might have traveled around 150 kilometers. So, the average velocity may be 100. But what was the velocity when I was at this point between cities A and B? So, the velocity at this instant of time is termed as instantaneous velocity. Okay? The velocity at that instant of time, at that fraction of a second, can be called as instantaneous velocity. Velocity of a body at a particular instant. How do I mathematically represent it? The limit of the average velocity as the time interval delta t tends to 0. Limit delta x by delta t as delta t tends to 0. It is the differential of displacement with respect to time. So, instantaneous velocity is the velocity at that particular instant of time. Then what is instantaneous speed? Instantaneous speed, if you have to check at some instant of time, have a look at the speedometer. Whatever is the display on the speedometer at that moment of time, that gives you what is instantaneous speed. It is at an instant, okay, whatever speed is being displayed on the speedometer at that instant of time can be called as the instantaneous speed. Speedometer will give you the instantaneous speed. If you have to work it out mathematically, the magnitude of the velocity vector can also give you instantaneous speed. Let us check the differences between speed and velocity. Speed is the rate of change of position, whereas velocity is the rate of change of displacement. Speed is a scalar quantity. Remember, I only tell the magnitude there. I am not telling the direction. Vector quantity is velocity. Velocity is a vector quantity because along with the speed, say 10 meter per second, I am also representing in which direction it is traveling. The direction of travel is also being told to you. That is why it becomes a vector quantity. It is always a positive value. I cannot say that speed is minus 10 km per hour. Whereas velocity can be positive, it can be negative, or it can be 0. I have told you in the previous slides that how velocity can be negative or 0. The average speed cannot be 0. If I am traveling from city A to city B, I cannot say that I traveled at 0 average speed. But average velocity can be 0. If there is no change in either the speed or the direction, then the average velocity will remain 0. You will study these concepts when you move into the next chapter. What is acceleration? See, we have studied this in a very methodical way. We first checked what was path length. We checked what was displacement. Rate of change of displacement is velocity. Now we have moved on to acceleration. Acceleration is rate of change of velocity, or how velocity changes with respect to time. Change in velocity by time taken can be termed as acceleration. The unit for acceleration is meter per second square. It is given by the equation A is equal to V2 minus V1 by T, where V2 is the final velocity, V1 is the initial velocity or the velocity at the starting point. Okay, T is the time taken by the body to travel from V1 velocity to V2 velocity. Okay, so this is acceleration. Please remember, whenever a body changes its position, it is called as displacement. Rate of change of displacement is called as velocity. Rate of change of velocity is termed as acceleration. Here we have purposely mentioned increase in velocity is called as acceleration. See, if you are pressing the accelerator of your car, it is going at a higher velocity. It is called as positive acceleration. If you are pressing the brake, the velocity is reducing. Even then, there is acceleration, but it is called as negative acceleration, or it is also called as deceleration. It is also termed as retardation. Whenever there is reduction in velocity, it is called as negative acceleration or deceleration or retardation. Whenever there is increase in velocity, I call it as acceleration. Okay, let us check. If the car is slowing down, the acceleration is in the negative direction. Okay, if the car is speeding up, the velocity and acceleration are both increasing. Acceleration is the rate of change of velocity. It may be positive or it may be negative. Positive acceleration in the direction it is moving, or the speed is going upwards. If you are riding your bike or your bicycle, you press it harder so that the speed increases. This is a typical example of positive acceleration. Whereas for negative, the accelerates in the opposite direction to its movement, or there is a slowing down of the vehicle. How does it typically happen? You are moving on the road, someone comes in between, you just push the brake or press the brake. So when you apply the brakes, your vehicle slows down. This slowing down is called as negative acceleration. What is uniform acceleration? We saw what was positive acceleration when velocity increases, negative acceleration when velocity decreases. Let us check what is uniform acceleration. If the velocity of a body changes by equal amounts in equal intervals of time, that interval of time may be smaller if required, then the acceleration is termed to be uniform. What does this mean? How does this happen? See, you have started your vehicle from your home. Initial velocity was 0. Okay? You press the accelerator. After 1 second, it increases to 1 meter per second. The velocity increases to 1 meter per second. 1 more second passes, it increases to 2 meter per second. Suppose 1 more second passes, it increases to 3 meter per second. It increases to 4, it increases to 5, so on and so forth. For every 1 second time period, the velocity is increasing by 1 meter per second. This is called as uniform acceleration. Okay, uniformly accelerated motion. Let us check what is average acceleration then. Average acceleration is taking into account the total change in velocity by the total time consumed. So whenever you are traveling from one city to another city, what was the total change in acceleration? What was the total time taken? That is represented by V2 minus V1 by T2 minus T1, or delta V by delta T. Average acceleration takes into account total change in velocity by the total time taken. Now, coming to what is instantaneous acceleration. Acceleration at that very instant of time. Okay, this is acceleration at this point of time. Whatever was the acceleration, that is termed as instantaneous acceleration. Okay, instantaneous acceleration is represented by limit of delta x by delta t as delta t tends to 0. It is also given by differential of x by time taken. Instantaneous acceleration is the acceleration at some instant of time. Okay, by this we come to the end of this class. Have a wonderful learning experience. Thank you.